Welcome to part 2 of a 3-part series on the long compass. In the first video we discussed how to make the long compass and use it to construct circular arcs with a very long radii. In this video we'll discuss why the long compass works and how to calculate the long compass settings for shorter radii. But first, so that we are all on the same page, we need to look at some definitions and properties of circles. By definition, a circle is the locus of all points that are equidistant from a fixed point in space. We call that the center, and we can use a drafting compass because it measures off a fixed distance, and we rotate it around that center and we create all the points that are equidistant from that center. This distance is what's called the radius, and the circle itself is called the circumference. If we take 2 points on the circumference, it divides the circumference into 2 parts, the minor arc and the major arc. We'll be concerned with the minor arc. Furthermore, if we take and connect these 2 points with a straight line, this line is called the chord, and there's a chord that's unique for any 2 points that we choose on the circumference. Here I've picked 2 points on the circumference and I've connected them with our chord. Now let's draw radius from these 2 points to the center, and then we'll pick an arbitrary point along the minor arc, say here, and we'll also draw a radius connecting it to the center. Here's our 3 radii, and then I connected the 3 points with shorter chords. What we want to do is examine this angle between these shorter chords. The circle has 360 degrees, and our chord divided the arc into 2 angles. The minor arc has an angle we'll call A, and the major arc has an angle we'll call that B. We can take and divide this minor angle A into 2 parts. One part for this triangle, one part for that triangle. We'll call this A1 and this one A2. Let's look at this triangle. Because this and this radii are of equal length, this is an isosceles triangle, so these 2 angles are equal. And what are they? Well, a triangle has 180 degrees in it, and we can figure those angles by subtracting out A1 and then dividing it by 2 because there's 2 equal angles there. And likewise, we can do the same for this triangle. This angle is equal to this angle because this is an isosceles triangle, and the size of that angle is equal to 180 degrees minus A2, and since there's 2 angles, they're divided by 2. Now we have enough information to determine what this angle is. It's the sum of these 2 isosceles triangle angles, which is these 2 angles, so we can add them together to get that angle. We'll call that angle L for our long compass angle. So our angle L is equal to 180 degrees minus A1 divided by 2 plus 180 degrees minus A2 all divided by 2. And we can simplify that. That's equal to 360 degrees minus A1 plus A2 all divided by 2. Well, what's A1 plus A2? Well, that's A. And what's 360 degrees minus A? Well, this is 360 degrees, and subtract out A, and that's equal to B. So L is equal to B, the angle of the major arc, divided by 2. So to recap, we can take any 2 points on the circumference of a circle, which defines a chord. And then we can pick any arbitrary point on the minor arc, say here, or it could be here, 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 wherever, and connect that point with straight lines to the end of the chord. That angle is constant, and we know it's equal to 1/2 the exterior angle, or the angle of the major arc. If we extend these segments of line out beyond the edge of the arc, and we imagine these points are nails, there you can see is our long compass. Let's try it with our long compass set at 90 degrees. I can use this triangle for that. And a long compass angle of 90 degrees would correspond to a major arc angle of 180 degrees, which is a semicircle. So the line, our chord, is actually going to be a diameter. And you can see that by keeping the long compass in contact with the end pins, it creates a locus of points. It's a semicircle. Here I've set this protractor up to 170 degrees, and you can see it creates an arc that's a lot flatter. In practice, as we saw in our last video, the input data that we usually have is the length of the beam and the amount of camber that we want to put into it. So we'll have to start with these two pieces of information in order to calculate what our long compass angle is. Our first step is to determine the radius of our arc. We're given the length of the beam, W, and the camber height. And when we constructed our camber, our timber, we measured over halfway. That makes the maximum height of the arc. That's our camber. And so we can split the length of that beam in half, and we'll call that the half width, W. And then the length of the radius that is on the inner side of the chord, we'll call that the co-camber, K. And we can see from this right triangle that R squared is equal to K squared plus W squared. And K is equal to the radius minus C, so we can substitute that in there. And we'll expand out that term. So we get R squared equals R squared minus 2RC plus C squared plus W squared. And the R's cancel out, and we can bring this term to the other side, so we have 2RC is equal to C squared plus W squared, and then we can divide by 2C to get R. So our radius is equal to C squared plus W squared divided by 2C. Our next task is to determine what the arc angle A is. We remember from previous work that the long compass angle L is equal to 360 degrees minus A divided by 2, half of this angle. Let's take a look at this triangle right here. I define this angle as the angle between, let's say, our plank and the long compass. So we'll call it the plank angle. We can see that that angle plus half of our long compass angle is equal to 90 degrees because this is a right triangle. So we can say L over 2, which is, simplify this, that's 90 minus A over 4, plus P is equal to 90. And so we can see this cancels out, and we can see that this plank angle is equal to our arc angle divided by 4. And the plank angle is quite easy to figure because we know the camber C and we know our half width W, and so the tangent of the plank angle is equal to C over W, and then we can find out what the tangent is, and then look in the tables and find out what the plank angle is, P, and all we have to do is multiply it by 4 to get A. You'll remember in the shop that we put 3 nails into our plank, and when we created our long compass angle, we used it so that we would go between 2 nails and then switch and use another set of 2 nails. So in actuality, what we want to do is get the offset off of a cord between our camber height nail and the end of the plank, which I've shown here. I've drawn a radius in that's from that point down to the center, and you can see it divides A into 4 pieces. So this angle right in here is A over 4, and we've already calculated that. And this is, of course, the radius. This line here, from here to here, that's the cosine of this triangle. So this is length, that would be the radius cosine of A over 4. So our offset is R, the whole length, minus this amount. So that's equal to our offset. We know R, and we know alpha over, or the arc angle over divided by 4, so we can calculate our offset. It's that simple. Let's do an example. Let's have a beam of 8 feet, so our half width will be 4 feet, with a camber of 6 inches, or a half a foot. We can calculate our radius using our formula, W squared plus C squared over 2C. In this case, that'd be 4 squared is 16 plus C squared, which is be 1/4, divided by 2C, that'd be 1, divided by 1, so that comes out to be 16 1/4 feet. The tangent of our arc angle divided by 4 is C over W. That'd be 1/2 divided by 4, that equals 1/8. So now our offset will be our radius 16.25 minus 16.25 times the cosine of our quarter angle. Let's calculate out what that quarter angle is in the cosine. We put in 0.125 for 1/8, and we'll find out what the cosine is, what the tangent is. And it comes out to be about 7.12 degrees. The cosine of that is 0.99227, etc. And we'll just go ahead and multiply that by R, which is 16.25. That comes out to be 16.1245. And we can subtract that from 16.25. And that comes out to be 125, or 1/8 of a foot. So out in the shop, then, on our beam, would lay out 2 nails that are 8 feet apart, measure up our camber, which in this case was 6 inches, and put a 3rd nail there. Then we would connect the center nail with either of the end nails. Let's choose this one. Find its midpoint, and then measure the offset for our long compass which in our case was 1/8 of a foot. I said 1/8 inch earlier, I'm sorry. And 1/8, that's 1.5 inches. And then we'd glue our long compass into position with that angle set in there. Now notice that's approximately 1/4 of the camber. And when we're using the long compass with the rule of thumb, we would make this offset half. Why is that? Well, when the radius is quite large, then this hypotenuse of this triangle is very much the same as this. And you remember in the shop, what we did was we measured half of this camber. In this case, it'd be 3 inches, but we worked off both of the end nails. So we scaled up the operation on a 2-to-1 ratio. So that's why this is only 1/4 instead of 1/2 the camber. This works as long as this hypotenuse or this arc angle divided by 4 is fairly small. Let's do another example where this is a little larger, and you'll see that the rule of thumb doesn't work. In this example, we use the same beam of 8 feet, so the half width will be 4 feet, but we'll increase the camber to 2 feet. So our radius then will be w squared plus c squared divided by 2c. W squared is 16, c squared is 4, divided by 2c, that would be divided by 4. That's 20 divided by 4, that's equal to 5 feet. The tangent of the angle will be c divided by w, 2 divided by 4, or the tangent will be 0.5. Our offset then will be 5 feet minus 5 feet times the cosine of a over 4. So let's go ahead and calculate out what that angle is using the tangent formula, and then finding what the cosine is. We know the tangent is 0.5. So that angle is 26.56 degrees, and then we'll find out what the cosine of that angle is. It's 0.8944, and then we'll multiply that by r, which is 5. And we get 4.47213. We'll subtract that from 5. And we get the answer of 0.527 feet. In this case, if we would have used our rule of thumb, we would have taken the camber of 2 feet and divided it by 2, and that would have been an offset of 1 foot. And if we want to double this up so we can compare, we would have, this comes out to be roughly 1.06. So our rule of thumb method is off by about 6%. In our third part to this series, we will take a look at how to construct a shallow long arc by generating the offsets and then using a batten to connect the offset points.